We'll see about the introduction about the physical layer. The main keywords covered in this video is physical layer, electromagnetic spectrum, copper wire, radio waves, microwaves, multiplexing, demultiplexing, NIC card, network interface card, LAN adapter, LAN card, analog waves, digital waves, Manchester encoding, FDM, frequency division multiplexing, TDM, time division multiplexing. The content covered from the book Computer Networks by Bhushan Trivedi, Oxford University Press. Physical layer. The first duty of the physical layer is that it passes the raw bit from one end to the another end into the network. So in this video, that is the truck, and we may compare this truck as a communication medium, means cable, that may be a twisted pair or the fiber optics cable. The job of the fiber optics cable is that to carry the data from one end to the another end into the network. So in this truck, this is the container, and it is used as a communication medium. In this thing container, there are the three data 1, 2 and 3. So three data are passing from one end to the another end into the network. If we compare this thing with the physical layer into the computer network, then the job of the physical layer is that to transfer the data 1, 2 and 3 using the communication medium like twisted pair, fiber optics cable, like that, from one end to the another end, means passes the raw bits from one end to the another end. Duties of the physical layer is that it carry bit from one end to the another using the electromagnetic waves, like the copper wire in case of the radio waves, and the microwaves, fiber optics wire, it transfer using the optical waves. So whatever the data covering from getting from the above layer, that is the data link layer, it received by the physical layer. Physical layer convert the frame into the raw bits, and the raw bits are transferred using the transmission medium bit by bit to the receiver physical layer. Again, at the receiver side, the physical layer it convert the signal into the raw bits. In this figure, this one is the sender and this is the receiver. The raw bit again transferred into the signal and the communication channel. It may be a wired or wireless technology. It transferred the data from one end to the another end with the help of the signal, and again this signal convert into the bits at the receiver side. Again, the one more job of the physical layer is that only the intended party can receive the data, means the sender sends some data 1, 2 and 3 to the different receiver at the receiver side. Then it should be take care about the physical layer that the whatever data sent from the sender is received correctly at the particular receiver only. No another user can get the data. More one job is the synchronization, to make the synchronization between the sender and the receiver, that the sender, whatever the sender sending the data, it correctly received at the receiver side, means the mismatch problem cannot appear. Faster the sender and slower the receiver. In this figure, sender send the data having the double speed, and the receiver cannot able to receive the data at the same speed. Means it may create the problem like the data overlapping, data mismatch problem, like that. So whatever the data sent from the sender side at the particular speed, make the synchronization between the two parties so that the proper communication can get established. Multiplexing and demultiplexing, no doubt the job of the multiplexing and demultiplexing is the job of the all the layer present into the network, but some of the portion of multiplexing and demultiplexing again cover into the physical layer. Machine port level addressing. Suppose this is the router and the number of routers present into the network, and there are the four network 1, 2, 3 and 4 having the different number of computers present into the different network. So in this example, this is the router having the 3 NIC 1, 2 and 3. Some data appear at this router, and our receiver present into the network number 4. Means this is the job of the physical layer, that is whatever the data at the particular router send to the receiver computer in a particular network, which router it should use, either R1, R3, R4 or R2, finally sending that data. So machine level port addressing is done at the physical layer side. Transferring bit, it may be analog waves or the digital waves. It use the different coding mechanism techniques. In a wired mechanism transmission, Manchester encoding. See in this one, binary encoding means a higher bit represent using the 1 is represent using the high voltage and 0 is represent using the low voltage. In a Manchester encoding, 1 is represent like this and 0 is represent like this. So there are the number of coding mechanism techniques are there for data representation. We will see in a next video. In a wireless transmission, it used the different technique like CDMA and OFDM. The next job of the physical layer is that synchronizing the sender and the receiver, as we discussed. Self-synchronization is achieved into the Manchester encoding. Here 0 is represent like in this fashion, 0 and 1. So this is the 0 is represent like this fashion, or this one, high and second low, and 1 is represent like that, first low and next part is high. Multiplexing multiple data stream. Example, suppose we are living in a society and there are the 100 houses in a society, and assume that all the houses from 1 to 100 having a single telephone line in each house. At the outside of the society there is one tower, and that tower contains a single box where all the cables of the 100 house may combine into that box, and that box carry a single very high bandwidth cable, and all the data from the different 100 cables now carried on a single high bandwidth data up to the telephone exchange or more, using the Cat5 or fiber optics cable. Second example is the internet cable. Suppose we have given a single internet connection line. It may be, say for example, 2 Mbps or like that. So we have the 2 Mbps line, our neighbor has the 2 Mbps line, and some more neighbors having the 2 Mbps line. But at the receiver side, means at the ISP, it has a larger bandwidth cable. That is the fiber optics cable. So that is called as the multiplexing. Something we should know, FDM, TDM, as we have seen into the previous video lecture, those are the popular into the telephonic signaling, broadcasting, television signaling or radio signaling, because it are helpful when the data flow is constant. Means when we on the television, then the its traffic is constant up to when we close our television or turn off our radio. So FDM or the TDM are better suited for the fixed traffic where the traffic is constant. But in case of the computer traffic, because it is not the constant like telephone or television traffic, say for example, suppose I want to read a newspaper, so I will use the Mozilla or some browser and type the www.thenewspaper.com, and at that moment of time suddenly the traffic will increase and the particular page number 1 will entirely load on in my terminal. After successful loading of the page, at that time the traffic was very high, but after the page download completed, then the traffic suddenly comes from 100 to 0, means there is no traffic, and maybe I will spend 2 to 5 minutes for reading a page number 1 of a newspaper. After reading that page, I will jump on the another page number 2, or will click on the some hyperlink. So at that time my traffic will suddenly increase from 0 to 100%. So such cases FDM TDM is not suitable for the burst data. In this figure there are the 5 sender 1 2 3 4 5. In FDM or TDM, we allocate the specific time slot to the user for transferring the data if all the senders have the data. So this is the sender number 1, it has the data, so we are giving 1 second for him, say for example, to transfer the data. After the second number 1, we will give the another time slot to the user number 2, 3, 4 and 5. After this cycle number 1, again the cycle will repeat in FDM or TDM. But assume that the situation is like that there are the 5 senders, but out of them only sender number 2 has the data to transfer the has the data for transfer into the network, and the rest of the user are having the no data. Still their slot is allocated, so the user number 2 will get the chance to transfer the data into the network at the time period slot number 2. After this cycle will complete, the user or the sender number 2 will get the chance for transferring the data. So that is the unuse of the bandwidth into the network when the no more sender are interested to send the data into the network. But what actually happen if there is no data, no sender want to transfer the data except 2, then all the bandwidth should constantly allocate to the user number 2, because he or she is only the sender into the network to transfer the data. So that is the best optimized use of the bandwidth. Now we switch on the one more topic, that is the electromagnetic spectrum. Try to visualize the thing covered into the image. This is the wavelength of the particular wave. We have the common waves, that is the radio wave, microwave, infrared, ultraviolet, soft X-ray, hard X-ray, gamma ray. Our topic normally cover the radio wave, microwave, infrared and the okay, so these are our main topic. Now see, radio waves, the wavelength of the radio wave is certainly up to the soccer or football field or the houses. The wavelength of the microwave is nearly like the ball or a person, and some more informations are given, like the source of the radio waves are tower, like that. The microwave, the information are given to you. Frequency, the radio wave, the frequency of the radio wave is nearer about 10 raised to 6 to 10 raised to 8, and the more information is given in it. Now we will try to see the radio wave. Before that, characteristics of the electromagnetic waves. First one is the frequency. Frequency is the number of times wave oscillate in a unit of time. So this is the second number 1. In a 1 second, the total number of frequency generate is 5. 1, 2, 3, 4 and 5. So thus the frequency is 5 Hertz. Second example, in a 1 second, the frequency generate 10 times. So it is called as the 10 Hertz. Second is the wavelength, distance between the two amplitude. What is the amplitude? Amplitude is the highest, means height of the highest height of the wavelength. So that is the amplitude of the wave number 1, and that is the amplitude of the wave number 2. So we can say this is the wavelength, this one is the wavelength. Wavelength with the higher power and thus the higher amplitude, and the wavelength having the lower power, it has the lower power, so the thus smaller amplitude, that is called as the amplitude, highest amplitude, and that is the lowest amplitude. And third characteristic is the power. It is calculated by the amplitude of the wave. Wave loses their power gradually, hence after covering certain distance, amplitude reduce as they proceed further. Important topic is radio waves. That is the lowest part of the spectrum operate in a given range. In it the frequency is very less, but the waves are long. In the figure see the radio wave. The size of the radio wave is just like the building or the football ground or the human. So as we gradually goes down, the wavelength, the size of the wavelength is decrease, but the frequency increase. So that is the relation between the frequency and the wavelength. That is the figure of the how the radio waves working in the current environment. So this is the sending tower, and this one is both are the receiving tower. Normally the radio waves appear in a two parts, ground wave and the another wave. So ground waves, normally the ground waves travels in a curve fashion. So this is the radio wave travels from one desk to one tower to the another tower, and another waves can directly transfer into the ionosphere or refract back on a earth surface. We'll see. Radio wave, it travels in all directional, so that those called are as the omnidirectional, that is the travel in a 360 degree. The benefit of the omnidirectional is that these waves can easily transfer or pass through the obstacle without any much more trouble, so that they can traverse a long distance. So when you have a radio set, there is no need to make a align with the tower, with the main base tower and the radio handset tower. So we can easily get or enjoy the song while we are sitting in a car, or we are in a room number 1 to room number 2 transfer. But there is a limitation of the radio wave is that poor candidate for the data transmission. Will see later on. Again, the radio waves are normally divided in two parts. First one is the ground waves. It is subdivided into the very low frequency, medium frequency, and second part is the high frequency and the very high frequency. So the first part is known as the ground wave, and it covers the very low frequency, and the medium frequency waves. So those are this is the example of the ground wave, and that is the ground wave. And second category is the high frequency and very high frequency. It travel in a straight line of sight, LOS, line of sight. Those are not the curve fashion, they traverse in a straight direction, line of sight, LOS. High frequency and very high frequency refracted back by the ionosphere. Normally ionosphere, environment of the ionosphere after the 75 or 80 kilometers from the earth surface. So this is the earth surface, and this is the sender tower, and this one is the receiver tower. Those waves are the high frequency and very high frequency. They can traverse in a straight in a sky, and when there is the ionosphere, it refract back to on the earth's surface. See, this is the sea level. As we know, the sea level is the zero, that is the earth, and this one is the Mount Everest. We know that the height of the Mount Everest is 8,848 meter, that is the almost 8 to 9 kilometer. So this is the representing the same thing. Now here, what is our need? Our need is finding the ionosphere. This one is the ionosphere, nearer about the 70-75 kilometers from the sea surface, and the range of this one is up to the 1000 or more. So when a very high frequency or high frequency wave appear from the radio waves, those travels in a straight direction, and they can traverse in a straight direction, and after they can reach at the ionosphere, they refract back into the earth's surface. This is the thing which I want to cover. Again, that is the earth sender tower, and this one is the receiver. Yellow sign or yellow color indicate the low frequency, or the medium means the ground wave, and these 1, 2 and 3 waves represent the very high frequency or the high frequency wave. Some waves can traverse straight line of sight up to the ionosphere, and from there they again refract back on a earth surface. So this thing is represented in a figure. But very high frequency waves, radio waves, can still traverse after crossing the ionosphere. And microwave, it operates at the said range. It travels the straighter, not in all direction like the radio waves, means the omnidirectional. Sender and receiver not perfectly aligned, still transmit the data with the lower rate. Means microwave can work best when both the sender and receiver are perpendicular, means they are very good aligned with each other, like a television dish and the satellite. If the television dish is exactly aligned with the satellite, then we are covering or getting good picture quality. If it's slightly rotate, then we measure the change. Okay, radio wave, this one is the microwave. So it is not required that must sender and receiver must align with each other, but if they are not aligned with each other perfectly, then we can transfer the data but having a low rate. So line of sight LOS is must, so sender and the receiver must align with each other if the perfect data transmission required without any disturb. This is called as the line of sight. Perpendicular means television dish and this main base station must align with each other. For that it use the parabolic antenna. We'll see the detail about the parabolic antenna into the next video. Do not penetrate through the wall. Microwave do not penetrate through the wall as like the radio wave. Radio wave can easily transfer from the obstacle or the wall. There are the problems with the microwave. Microwaves above 4 gigahertz absorbed by the raindrops, and second problem is the multipath fading. But it has the advantage that no wiring between the sender and the receiver. Only two things is required. One is the antenna and second one is the tower. If you have these two things, then we can easily transfer the data using the microwave. So the cost, it is the inexpensive, we can say. No wiring between the sender and the receiver. Second advantage is that it is relative inexpensive and again cover 50 to 60 kilometers. But for that licensing is required. In the US, this job is done by the FCC, means Federal Communication Commission. In India, this is done by the Department of Telecommunication, DOT department. This is the person who is the minister of the DOT in the USA. This one is the main person, key person for the FCC on today, that is the 14th March 2016. So in this video we have covered physical layer, electromagnetic spectrum, copper wire, radio waves, microwaves, multiplexing, demultiplexing, NIC card, network interface card, LAN adapter, analog waves, digital waves, Manchester encoding, FDM, frequency division multiplexing, TDM, time division multiplexing, etc. Thank you very much.